Welcome to qnawire.
A star with a name I won't attempt to pronounce is 57 light years away from us, and it has a mass of 0.85 times that of our Sun. There's a planet that is 0.11 times the distance that we are away from the Sun, and we want to then know in part A what is the orbital velocity of this planet around that star. So, as we've been using a lot in this section, we know that for any object in circular orbits, its orbital velocity is just the square root of g times the mass, usually we'd say of the planet, I guess we'll say of the star here, so the mass of the object being orbited, divided by the orbital distance r. So they've given us these in terms of values that we know, so we'll just substitute those in. So g, and then the mass of this planet is 0.85 times the mass of the Sun, and the distance is 0.11 times the distance between the Sun to the Earth. So we look up those values in the appendix, and we should get that the velocity is 82,700 meters per second. So that's part A. And then in part B, they want to know what the orbital period is. So the period is just the distance traveled in one cycle, the circumference, 2 pi r, divided by the velocity. So 2 pi, and again for r, 0.11 times the distance of the Sun to the Earth, and then divided by that velocity we just found, 82,700 meters per second. And we should find that that is about 1.25 times 10 to the 6th seconds. And I don't have a great sense of what that is, so we do a bit of converting, and we find that it's about 14.5 days.